Good morning, Alf. Pleasure to have you on behalf of Searchlight Resources. You're the chairman, and you have some exciting bycatch to report. I would almost dare to say, which is a uranium find, which wasn't really what you were planning for in the Athabasca Basin. I think that sets the stage for our discussion today, and the floor is yours to walk us through different, let's say, aspects of that discovery, where it is, and what it might mean down the road.
Very good, Sven. Thank you very much for hosting me. Yes, Searchlight is a Saskatchewan-focused junior exploration company with a very modest market value. Our market valuation is about $7 million as we sit, but we're exploring in elephant country, and we're focused on new energy commodities, things that will be involved in the green energy revolution that we see happening before us right now. And we believe that Saskatchewan is one of the best places in the world to be exploring for new energy commodities. And we've been exploring primarily for rare earths in northern Saskatchewan at our property called Kulik Lake. Saskatchewan is actually known primarily for a number of commodities, notably uranium. Uranium deposits in Saskatchewan are 10 times the average grade of uranium deposits anywhere else in the world. And we are exploring very close to the major uranium deposit area in northern Saskatchewan, and it's called the Athabasca Basin. And this demonstration we have in front of you shows the Athabasca Basin on the right-hand side, and it shows all of the major uranium mines in the Athabasca Basin on the eastern edge here. And we've got deposits such as Wheeler River, MacArthur River, Cigar Lake, Rabbit Lake, and McLean Lake. And I've personally been involved in uranium exploration since the 1970s. I started my career as a young geologist looking for uranium in Eastern Canada. And in 1979, I was shipped up to northern Saskatchewan to drill one of the very first uranium discoveries in the area. It's called Midwest Lake. If you look at the profile of deposits on the left-hand side of this slide, you'll see Midwest Lake right here. Mm-hmm. Now, what's interesting about the Athabasca Basin is our understanding of the deposits in this area has evolved over time. The very first deposit that was ever found is called Rabbit Lake, and it was found right at the edge of the Athabasca Basin, which is really a sandstone deposit that sits over older basement rocks. So the first question that geologists had is, well, should we be looking in the sandstone or should we be looking in the basement? And here it is, 50 years later, we're still asking the same question, and there is no wrong answer. The uranium occurs both in the basin and it occurs outside the basin. So this is what's exciting. Our property, Kulik Lake, is just outside the Athabasca Basin, and it includes one of the highest rare earths deposits in Canada. It's historically known. Academic papers have been written about it. The rare earth grades exceed 50%, and it's never been drilled. It's just been studied as a geological curiosity. So we initiated a program this summer, and we flew a survey looking for rare earths. And accidentally, we found uranium, and it fits very coherently into a story which I'm about to tell you. So looking at this section of the deposits in the Athabasca Basin, you'll notice that most of the deposits sit right along the boundary between the gray basement rocks and the sandstone. You've got Key Lake, McLean Lake, Midwest Lake, Rough Rider, Cigar Lake. These are all major uranium mines, mostly owned and operated by Cameco, and mostly over on the east side of the Athabasca Basin. But they sit right at the contact between the basement and the overlying sandstone. But about 10 years ago, a company called Fission Uranium made a new discovery, and it's over on the west side of the basin. It's called Triple R, also known as Patterson Lake South. And it's shown on this slide as the extreme left side. And what you'll notice about the triple R, it's nowhere near the sandstone. It's exclusively in the basement. Shortly after the triple R deposit was found, another company called Next Gen Uranium found another deposit called Arrow. So these two companies collectively represent more than $3 billion worth of new discoveries, and they're entirely in the basement rocks, which is where we're exploring. So we're exploring our property just south of the Athabasca Basin, looking for rare earths, and we've stumbled upon uranium. So let's talk about what we've done. We're sitting in what's called the Wollaston Domain, which is the basement rock right under the Athabasca Basin on the eastern side. And the companies in northern Saskatchewan have significant market values. Next Gen Uranium, 3.6 billion, Fission, 698 million, Sky Harbor, 120 million, Baseload, 65 million. Only the first two companies on this slide actually have measured uranium resources of significance. These other companies are all smaller explorers without a significant uranium resource at this point. And I'm also putting on this slide our competitors that are looking for rare earths in northern Saskatchewan. A company called Appia Energy has a market valuation of about $81 million. And Searchlight's at the bottom of the slide, we have a market cap of 6 million. So just a fraction of the other companies that are exploring in the area. So this is a different representation of essentially the same geographic area. On the right-hand side, we've got the Athabasca sandstone shown as this Athabasca Basin area. And then just on the eastern edge of it, we have what's called the Wollaston Domain. And within the middle of the Wollaston Domain, we have Searchlight's claims. And then on the left-hand side of the slide, I've blown this up to show our claim area in more detail, and our claims are shown in red. And we've out here 2-3 months ago, it was only us. Nobody else was looking out here. We were quietly exploring for rare earths. And then all of a sudden, all of these uranium companies came in and staked all around us. So we have Pure Point Uranium, one of the companies I just showed on the previous slide. The exploration manager for Fission Uranium is staked directly adjacent to us here. His name is Ross McElroy. And then we have Sky Harbor, Rio Tinto, and others. So all of a sudden, this area is now extremely hot when looking for uranium.
And that has to do with the obviously elevated uranium price, or is there some technological reason or behind that?
It's based on the uranium price. Uranium has been in a bear market for many, many years, and the supply-demand situation has just tightened up, in part because Japan has restarted its nuclear program. You may recall that back in 2011, Japan was hit with a massive earthquake and tidal wave, and there was a nuclear accident at Fukushima, and Japan shut down its entire nuclear industry. 17 reactors were shut down, and Japan started to liquidate its uranium inventory. Well, they've been gradually, one by one, restarting their nuclear reactors. And as a consequence, the uranium market has shifted from being oversupplied to undersupplied and in demand. So uranium prices have moved up, and this is reflected through to a renewed interest in looking for uranium in the best place in the world.
Yes.
So now I want to talk about how uranium discoveries have been found in this basement outside of the Athabasca Basin. And we have a picture of two very intrepid geophysicists with their airplane, and they've got a special black box that looks for uranium and thorium. Now, why would we look for thorium? Thorium is an essential element in the mineral that hosts rare earths. Yes. So if we fly a survey looking for radioactivity, we can simultaneously look for thorium and uranium, and we know which is which based on their response. So these guys fly this fixed wing aircraft at about 50 meters over the treetops with a black box in it looking for radioactivity. And back in 2011, they detected an area at Patterson Lake South, 2 kilometers long and with high grade uranium. And they can tell their instrument has a very narrow window and it looks directly below the airplane. And they can tell within 50 meters when they go across uranium mineralization exactly where it is. And their instrument is tuned to detect high-grade uranium hotspots. So they found this area for fission uranium, and that led to the discovery of a $600 million uranium deposit. We just announced this week that we have completed the same survey on our Kulik Lake property, and we have the same kind of response. So
very unexpected. Though.
We knew
the surprise of those two gentlemen as well, I guess.
Yes. Well, they called us and said, we want to tell you specifically that the nature and the shape of the peaks indicate that you have high-grade uranium at surface. They tell us that their survey technique cannot detect anything deeper than 1 meter. So the uranium mineralization must be sitting at surface, not buried hundreds of meters deep. It must be at surface. It must be high grade. And they hit this response on several lines as they flew over our area. And I'll get into the map here in a minute. Mm-hmm. But we did know there was uranium on our property. It's just most of the showings on our Kulik Lake property were of no consequence or size.
Yes.
And we had numerous indications of uranium in the survey, but what's really revealing is the large area that they've detected with this survey. And this is our survey results. Shown in red are the high-grade uranium indications from the airborne survey. So they're flying their survey 50 meters over the treetops, and they're flying lines that are 50 meters apart. And they have found this area in the middle, this large red area, about 2 kilometers long with high-grade uranium. And what's interesting about this is there are no known uranium occurrences anywhere within this high-grade area. There are other uranium showings further to the northeast at Kulik Lake. Historically, we know there's uranium on the property, but this new area is a complete surprise that it's a large area, that it's strong, and that has a similar signature to the Patterson Lake South discovery that fission uranium made. So we're very excited about that. We have obviously a major target to follow up with our spring exploration program early next year. We're not going to do any further work on uranium this year because it's late in the season and it's very dangerous to fly when there's snowstorms and so on pending. So it's too late this year to follow up on this, but we're going to be following up early next year. This is I'm just going to go through one more slide. The monazite is the rare earth mineral, and it hosts rare earth elements like neodymium and praseodymium, which are important high technology elements specifically used in regenerative breaks. 90% of the world's supply comes from China. And with
let's skip the rare earth for the time being, if you don't mind. I'd like to stick with the uranium first, because
okay,
maybe you go back one slide again. My question really is, how accessible is this? How remote is this? Why wouldn't you just send somebody there on the ground with boots on the ground and drill a couple of auger holes to verify the grades?
Because it's a rather large area, and we want to do a systematic program over this entire area.
Okay.
And we think that program would take a couple of weeks, and we think it's the wrong time of the year to do that.
Okay. But again, how remote is this place? Is there a road somewhere nearby? I read it's about 65 kilometers away from the world's biggest uranium mill. So
yes,
that's
in the grand scheme of things, this is in tremendous infrastructure, because obviously if you find a uranium deposit, it's best if there's a uranium mine nearby that can process the ores. And there is a uranium mill within, conceptually, trucking distance, but there is no road to this property.
Yes.
So we are 30 kilometers from the nearest road, which is the road to the Key Lake uranium mill, and that exists 30 kilometers to the west of Kulik Lake. So in order to get to this property today, you fly in a float plane to this lake in the middle of the slide. That is Kulik Lake. And then you hike through the bush about 2 to 4 kilometers to get into this area. There are no roads.
Okay. Okay, so infrastructure in relative terms is not terrible, but it's also not great, I would say, right?
I would say, look at fission uranium. Is there any uranium mill near that $600 million uranium deposit? No.
Okay.
At this stage of the game, we're in better shape than Patterson Lake South when it was first discovered, because we just are fortunate in having the world's largest uranium mill within trucking distance. Building a road to a uranium mill is a lot easier than building a uranium mill out in the middle of nowhere.
That is not out of the question. Okay, I get it. You're going to do more exploration. In an ideal world, this is only the signature of the outcrop of a system that might run deeper, but that's probably the multi-million-dollar question here to be resolved in the next little while.
Two things. One is this directly reflecting the bedrock uranium mineralization?
Yes.
Or is it uranium boulders that have been pushed by glaciers a few kilometers from the source? In the case of fission uranium, the initial boulder field detected by the geophysics found the indications of uranium, but the actual deposit was 2 kilometers away. And it took further field work to prove that. Now, in this case, we don't yet know. And it's speculation to say whether this is direct indication of uranium in the bedrock or whether we have to go from finding boulders to tracing the source of the boulders. But we're close. Mm-hmm. And that's the exciting part of exploration. And that's why it isn't simply a matter of just going there and a day or two and finding it. We really need to systematically explore it.
I get it. Okay.
And yeah. And there are a couple of other things that we should do. We know that uranium deposits occur in carbonaceous rocks. The uranium floated around in the Earth's surface in oxidizing environments, and it got concentrated in reducing environments. Mm-hmm. So in these old terrains, you look for graphitic shales. We have another geophysics tool to do that. So we have a couple of things to do to make a discovery, and I'm very excited about it. But this is the major indication, and it's surprising to me that we're in the highest grade uranium area in the world. We're 65 kilometers from a major uranium mine, and yet this is sitting at surface.
Yeah.
Welcome to Saskatchewan.
Yeah, very, very interesting. And let's say recalling some of our previous conversations that we had, you mentioned that this property probably had been flown before, because there must have been suspicion of more uranium showings. Why would you think this was never picked up?
I think that the survey that we flew is very specific, and it's tuned with a very narrow field of view. It looks directly under the airplane, and it is specifically tuned to find high grade at surface showings. The previous surveys were too broad and not sensitive enough to find this response.
Yeah.
And it may be that conditions were a little different this year. It doesn't take a lot to cover up a uranium showing with say, water or swamp. You won't find a radioactive response under more than a meter of soil or any water. And this summer was the driest summer we've had in decades. Yeah. And we flew our survey in September after a prolonged drought. So I think that we had ideal survey conditions with a better black box. And so we've got better results.
And could you put into perspective, this is shown in red, and obviously it's the top of the scale, but honestly, what is 0.338 parts per million uranium? Is that?
It's a number on a scale against a theoretical model.
Yes.
So it's really all relative. Yeah. Typically, these kind of red numbers on this map could represent uranium mineralization between 20 and 50% uranium. We don't know exactly until we get down and look at the surface. But the geophysicists have told us these are indications of high-grade uranium, which is 1% plus. We don't know exactly. Yes. And the numbers in uranium parts per million is a theoretical model number, and it has no relationship to actual uranium assays.
Yeah. It would be interesting to compare this map with a similar map taken somewhere else, yes, you showed Patterson Lake South, which was obviously recorded by the same crew, but I can't recall the measurement there. Anyways,
again,
I think this gave a very good overview of what you're onto. I suggest we delay the rare earth to another discussion because I don't want to blur the picture right now. The rare earths are exciting in them by themselves, I would say. But for now, I'd really like to keep it at the uranium here. And well, I'm really looking forward to see Searchlight, develop into an energy metals company besides its gold portfolio, I would say.
Okay.
Okay, Alf, thank you for taking your time today, and we'll definitely keep posted. And why don't we basically set up something else for going through the rare earth stuff together?
Yes,